Unit 8A, Lesson D and E, deals with understanding slope as a rate of change. In the previous lessons you guys saw, you learned how to calculate slope given points, given a table, even from a graph. Okay, so basically now it's finding slope in word problems. Alright, let's take a look at our two objectives for today. Alright, by the end of this video, we hope that you can determine the slope of a line from word problems, and that you can recognize that mathematical slope is the rate of change in a real world problem and include the appropriate units. Okay, example 1. We're given a table and we're asked a few questions about rate of change. Remember, rate of change is the same thing as slope. Okay, so slope is rate of change. Okay, they're the same thing. Alright, so in example 1, we have this table, and you notice this table says this shows the total number of people who voted in District 5 at various times on election day. So at 8 a.m., 141 people voted. By 10 a.m., 351 people voted. That includes the 141 plus the additional people that showed up between 8 and 10. Alright, and it continues to grow each time because obviously we can't go back and pull people from voting. They've already voted. Okay, so part A says find the rate of change in the number of voters between 8 a.m. and 10 a.m. Then interpret its meaning. So what we're going to do first of all is find the rate of change. This is a table. So here's our x, here's our y, and what we're doing is finding slope. So I'm going to put my y on top, so I have the number of voters over time. And that's going to be equal to 351 minus 141 over 10 minus 8. Okay, so now it's just a matter of doing your calculations for slope. Okay, we have 351 minus 141. That gets me 210 over 2. Alright, and we do our division, we get 105. Okay, so notice we calculated slope same as we've been doing for the last few days. But now we have this idea, because we have a word problem, we have to interpret what this number actually means. Okay, what does 105 mean? Well, if you set this up before you do your slope and you tell yourself what you're finding, you know what the answer is. This is the number of voters per hour. So there are 105 voters per hour. Okay? So this setup that I put on the side is something you should have written down. Alright? And it's something we're going to do each time in these word problems, because every time it's as easy as looking back and saying, what the heck do these numbers represent? Oh yeah, numbers of voters over time. And then you're able to say what it means. Okay, part B says, find and describe the mistake the student made in the following problem. Alright, so the question is, find the rate of change in the number of voters between 10 a.m. and 1 p.m., then interpret its meaning. Okay, so here's my 10 a.m., here's my 1 p.m. Alright, so this person has set up their number of voters on top, which is what we did last time, over time on the bottom. So it looks good. They have 798 minus 351, and we have 1 minus 10. So 798 minus 351 is 447. That checks out. 1 minus 10 is negative 9. Okay, they divide this, they get negative 49.7, and they say that's the number of people that voted went down by about 50 people per hour. Obviously, that's not what's happening here. Alright, the number is clearly going up, not going down. So we do have a problem. Alright, and the problem comes with this number on the bottom. Okay, right here. Time works differently than regular numbers, because after every 12 hours it starts over again. So the time between 10 a.m. and 1 p.m. is not negative 9 hours. We didn't go back in time. Okay, we progressed. So what you need to do with time, all right, is either convert to military time if you know how to do that, or the easier way is just go ahead and count your time. Okay, so we want to go from 10 a.m. to 1 p.m. Okay, so that would mean 11 o'clock is 1 hour, noon would be the second hour, 1 p.m. is the third hour. So this is actually a difference of only 3 hours. Okay, not negative 9. So 447 divided by 3 is 149. Alright, and again, the meaning is there's 149 voters per hour. Alright, so time can be very tricky. You got to remember, if you cross over from AM to PM, or the other way around, alright, that it's better to just count out the time. Up here, in the example we did earlier, we went from AM to AM, so we just did a subtraction, no big deal. However, you may just want to choose to count the time. Alright, so we start at 8 o'clock, which means at 9 a.m., 1 hour has gone by, and at 10 a.m., 2 hours have gone by. So you notice we did do this correctly. Okay, you got to be really careful with those questions. Alright, you have some you try problems to do on your own. Alright, let's move on to the next set of examples. Alright, we have, at the end of 2010, Miss Johnson had 47 death metal songs on her iPod. At the end of 2013, she had 134. Find the rate of change in the number of death metal songs on Miss Johnson's iPod, and what does it mean? Okay, so what we have here are ordered pairs. Okay, we have an input, the year, and an output, how many death metal songs she has on her iPod. Alright, so my first point is 2010 and 47. My second point is 2013 and 134. Now we could use these numbers, or sometimes what we like to do is say the first year is year 0, and then count from there. So the end of 2010 is 0, alright, which means that the end of 2011 is 1, the end of 2012 is 2, and the end of 2013 is 3. So we could either use 2010, 2013, or we could use 0 and 3. You'll see them both used in different problems, so just so you know. Okay, so here's our 2 points. Alright, I'm going to set up my slope. So y always goes on top. So I have number of, I'm going to abbreviate there, death metal songs. And on the bottom we have the year. Okay, so we have 134 minus 47 over, I'm going to use 3 and 0, 3 minus 0. Alright, again, it doesn't really matter how you do it. Just make sure you're reading the directions, because sometimes they tell you one over the other. That's going to be 87 over 3, and that comes out to be 29. Okay? Now, once again, we're not just looking for the slope. Okay? We have to say what this means. And, again, if you set this little fraction up here first with where we're putting numbers and what they mean, it's really easy. Alright, she added 29 songs per year. Okay? B. Miss Geiger is on a hike. After 2 hours, she's at an altitude of 400 feet. After 6 hours, she's at an altitude of 700 feet. What is the average rate of change, and what does it mean? Okay, so once again, we're going to set up our points. 2 hours is the first thing we look at. Alright, at 2 hours, we know she's at 400 feet. So 2 hours is our input. Our output's 400. Alright, at 6 hours, she's at 700 feet. Alright, so what we have, alright, is her altitude over time. Alright, we set that up. We have 700 minus 400 over 6 minus 2. So you notice it's just the same as finding slope. Alright, and then we do 300 divided by 4, and we get 75. So what this means is she climbed 75 feet per hour. Alright. And question C, you'll notice once again we're back to the student mistake. Alright, we look at the question and we have to find the mistake. Okay, it says after 30 seconds, a rocket is 1 mile above the Earth. After 2.5 minutes, or 2.5 minutes, the rocket is 5 miles. What is the rate of change in miles per second, and what does it mean? Okay, so we're being told here, we want our answer in miles per second. Okay, what that means is miles are on top, seconds are on the bottom. Okay, and when we look at the numbers, 5 is a mile number, 1 is a mile number. Okay, so that's good. Then it's 5 minus 1 because we always do y2 minus y1. Alright, on the bottom, 2.5 is not in seconds. Okay, and that is a problem. Okay, so we have to convert the 2.5 into seconds. 2.5 minutes in a second. So there's 60 seconds in a minute, so that means 2 minutes will be 120. Alright, plus an additional 30 to make up for that half brings us to 150. So we should have 150 minus 30, which is 120. Alright, and then 40 divided by 120 is going to come out to be 0.03 repeating. Alright, so the rocket goes 0.03 repeating miles. And by the way, the negative number should clue you into something's wrong, because how can you possibly go a negative speed? It doesn't make sense. You're going negative miles per second, alright, or are you going positive miles in negative seconds? Either way, it doesn't make sense to have a negative number there. Okay, so using your logic could help you find these simple mistakes that we've seen in the 2 student errors so far. Alright, let's move on. You have your you try problems, okay, for you to do in class tomorrow. And finally, we get to our last example. Alright, and it says, which relation has a constant rate of change? And that means it's linear, meaning if you were to graph it, alright, which we've learned how to do already, alright, it produces a straight line. No bends or curves or twists or anything like that. Okay? And notice this select all that applies. That means we're not just finding one and stopping. We have to test all of these. Alright, so a constant rate of change means if I take these 2 points, this one and this one, and find the slope, it should be the same as this one and this one. Or this one and this one. Okay, so we could do it in any combination. So let's go ahead and take the first two. Alright, I have my x's here, my y's here. So my slope is going to be y2 minus y1. I'm calling this one obviously y1. And this one's y2. And this will be y2 in the next problem we'll see. Alright, over x2 minus x1. And we end up with 8 over 2, which is 4. Alright, so let's go ahead and test the next points. I'm going to call this one y1 and this one y2. So I'm comparing these 2 points now. Alright, so my slope is going to be y2 minus y1, which is 9, over x2. So obviously this is x2 and this is x1, minus x1. And I do my subtraction, I get 7 over 1. So that means my slope is 7. So in order to have a constant rate of change, obviously the slope needs to be the same, because constant means it's the same. It doesn't change. Well, it changed from 4 to 7, so I know right now this one does not have a constant rate of change. Alright, so for B there's a typo. Alright, it should be the point 5 and 25, not 5 and 50, so please make that correction. Let's go ahead and work on this problem. We have, this will be point 1 and this will be point 2. So we're going to find our slope. We have 10 minus negative 10. You got to be really careful with your signs here. And 2 minus negative 2. And what I like to do is leave change, or create the old mega plus. Alright. And now we have addition. So I have 20 over 4, which is 5. Okay. My second point I'm going to choose, or my second 2 points I'm going to choose, is going to be just like before. I'm going to take this one as point 2 and this one as point 1. Okay, remember there is a change in this bottom point, so hopefully you made that already. Alright, we have 25 minus 10 over 5 minus 2. So that's going to be 15 over 3. And 15 over 3 is 5. And we have a slope here and a slope here that's the same. So we have our first winner. This one has a constant rate of change. So let's move on to C. Because again, remember, select all that applies means you really need to check to make sure you're not missing anything. Alright, so for C, I have 0.1 and 0.2. I'm just doing the same thing here. Alright, I have 3 minus 2 over 9 minus 4, which is going to be equal to 1 over 5. Alright, and again, it doesn't matter which 2 points you choose as long as one of them is different. So what I'm going to do, just to show that, is I'm going to call this point 1 and I'm going to call this point 2. Alright, and do my second slope. So I have 5 minus 2 over 25 minus 4. And that's going to be 3 over 21, which is 1 over 7. And then once again we check and see 1 over 5 and 1 over 7 obviously not the same thing. So that is not one of the answers. And we only have one answer in this case, which is B. Okay? We have some U-tries for you to do on your own, and then make sure you are filling this out. Let us know what you can do, and if you, especially this one, if you're having any questions, let us know. We'll see you in class.